Now, I may have been slightly dramatic with this slide, but the Greek letters are quite important. So, I know I said you might jump out of your chair or whatever you're currently laying on for the symbol for micro, which I've covered in the last video, is this little symbol here. It's a Greek letter. So, there are 24 Greek letters, and a lot of them are used. Now, not all of them, only about 16 or so are fairly common. Some are used more than once and some aren't used, which is a bit weird, but that's just how physics works sometimes. So the table here shows all of the Greek letters. Now, the ones that are very important, alpha we will use, beta we will use, and gamma we will use. Delta we will use. Now, delta is a special one because it means a change in. I've never seen it be used for anything else in physics. I know it's used in the epsilon delta limit proof in calc, but I have rarely seen delta used for anything other than a change in. So if it's a change in velocity, you'd write it as delta v divided by delta t, so a change in velocity over time, which some calculus people might recognize as dv by dt. However, delta v over delta t is a more numerical approach to it. So epsilon we will see. Zeta we don't really see. Now the zeta function is commonly used. So the Riemann hypothesis, the $1 million Millennium Prize problem, involves a zeta function, but we're not going to be talking about the Greek letter zeta pretty much at all here. Eta we will use once for viscosity. Theta should be the one that everyone should be knowing at this point. It's used for angles. We will also use it for temperature measured in Kelvin. So delta theta is probably one of the most annoying things I've ever seen in a formulae, but delta theta is something we're going to have to see a lot in heat temperature. So a change in temperature is a delta theta. Iota you don't really have to care about. Iota doesn't really have much use. Kappa, again, not really. We'll see it when we get to dielectrics. Lambda, yes, we'll see it as wavelength. Mu, we've already seen, that's the symbol for micro. It's also the coefficient of friction. Nu, we don't really see until we get to the neutrino in about 20 chapters time. Xi, we never see. Omicron, we never see. Pi, obviously key. Other than the number, there's no other real use for it unless you talk about the pion. Again, when we get to that the thing in 20 chapters time. Rho is used for a couple things. Density and resistivity are the main ones. Sigma, yes, this baby sigma is the Stefan-Boltzmann constant, and the big sigma just means to sum up. So if it's the sum of forces in a given direction, you just sum up all the forces using vector addition. Tau, we sort of see, again, much like with eta and kappa, we only really see it in one chapter, and again that's in fluid dynamics. You will probably see it as well as the tauon, but again, not really much. Upsilon we never see. Phi we will see. It's commonly used for angles. It's also used for magnetic field strength. No, magnetic flux. It's flux. I got that wrong. It's magnetic flux for that. Magnetic field strength is B. Chi again we never really see. Psi we will see as the wave function, and omega we will see this as angular velocity or frequency, and this is actually the unit for ohms. So if you've ever done even a bit of electricity, would have known Ohm's law, where resistance is in ohms. That is a very badly drawn omega. I'll try to draw a better omega. Okay, much better. So those are really the main Greek letters that you come across. So I won't be going back to this a lot. I will just be saying them in the formulae, and I should hope you know which one's which if there's more than one in a formula.